Alright, let's take a look at the inverse trigonometric functions. So I'm going to start off by drawing our usual sine function, the first period of it, and we have any x value, we can get a y value. Now remember, an inverse function works the opposite way. So we take a y value and it gives you an x value. So the thing about periodic functions, if I draw this very small, say you pick the y value 1/2. Well, that's going to have sort of an infinite number of places infinite number of x values that will give you that y. So that's not a function, because the function takes each value and maps it to exactly one value. This works when we go with x. And sort of have to remember the vertical line test. If you want to make the inverse of the function, go the other way. And so there's a sort of horizontal line test. And this fails the horizontal line test miserably. However, we're going to restrict our function to just looking at this part here. The part that goes from, let's see, this is pi over 2, and this is minus pi over 2. I'm just going to look at this part. Here we can have an inverse function. For any particular value, if we have a half, we can see that it maps only to here. So we restrict the domain when we find the inverse sign. So we write the inverse sign. We usually write it as this. This is not to be confused with sine to the -1 power. That's not what that means. This just means inverse sine. It's also written, we'll do that today, equivalent. That's the arc sine. These words are equivalent. There's similarly for cosine. There's arc cosine and arc tangent. Sine, cosine, and tangent. Let's take a quick look at here's our cosine function, the first period. So when we take the arc sine, we only map into values that are here. So we're going to get a value between pi over 2 or minus pi over 2. Or if this is degrees, they'll go from 90 to minus 90. That's the value you'll get out of your calculator. Even if you take say the sine of, this is 3 pi over 2, sine of 3 pi over 2. Well, it's going to be -1. But when you take the arc sine, or inverse sine, of -1, it will map back to minus pi over 2. And you can choose a huge number like 64 pi over 2. And it'll map back into this little section here. Alright? Notice that when you take a sine of the sine of a angle, and you get back sort of a ratio, sort of a raw number between 1 and 0. When you take the arc sine, you take that raw number and you get a degree. You get degrees or radians, you get an angle out. Alright, so it's the inverse. We've dealt with other inverse functions, like logs are inverses of exponential functions. So when we do sine, we restrict what we look at to, let's see, this is pi here. Full period is 2 pi. We restrict our values to 0 and pi. So you always get something positive out for arc cosine. Those will map into this area. So these are different domains that you're going to get numbers out of. Or these domains. So you put in any angle, you will get something in this domain. The range is anything you can put in. Oops, did I say that backwards? Alright, range is what you get out. So it's the range, sorry. It's the range that goes from minus pi over 2 to pi over 2. The domain is any degree you can put in there. Okay? Your calculator does this easily. And similarly for tangent. Tangent, remember, goes like this. Pi over 2. Or maybe you don't remember it. This is what it does. It's minus pi over 2. We restrict our domain for tangent to the same thing as we do for a sine. Alright? One last thing about these. So it's pretty straightforward undoing these things. What you can do sometimes is you can do arc sine of, say, 3 over 5, and then turn around and right away take the cosine of that. Now you can do this in a calculator. I should have written that a little closer. So it's the cosine of the arc sine of 3/5. So 3/5 is a ratio, and we get the angle for that, and then we take the cosine of that angle. Well, maybe you recognize 3/5. So if this is our angle theta, 3, 5, this is the 3, 4, 5 triangle. Sine is opposite over hypotenuse. Okay? So you know it's this angle. And then we can take the cosine of this angle. We don't actually have to find what this angle is. It's like something nasty in degrees, like 37. But we don't have to find that even. We can just look at this and say, well, if we know that theta has a sine of 3/5, we know that cosine is going to be that same angle. It's cosine of that same angle. That's going to be 4/5. So we can do problems like that. Cosine. Well, let's just switch them around. One more example. Of 1 over square root of 2, or square root of 2 over 2. Alright, so we know that one square root of 2. So we know that this angle is going to be 45 degrees. And so this is the sine of 45, which again happens to be the same as cosine for 45. So this is 1 over square root of 2. Alright? But usually a function, taking the sine of a cosine will just undo that function. You get the same value back. Just as when you did e to the natural log of x gives you x. If you do sine of arc sine of x, you should get back x. With the warning that x will be in the range of pi over 2 to minus pi over 2 if it's sine, and it'll be a range of 0 to pi if it's cosine. Alright, so we'll try a few of these. And we'll play around with some things like these. It's always good to draw a picture when you get something like this. And you can usually solve it without your calculator. Or you can often solve these without your calculator. Remember, there's a few triangles that work out nicely. You can use the Pythagorean Theorem, even if they don't work out nicely, to find it. For example, if we had... I was going to make this short today. Sine, arc sine of x, cosine. So we want to find there's some angle whose sine would give you x, so that means whatever this angle is, that this over this is x, so it's sort of x over 1. Will you buy that? You can rewrite x as x over 1. So whatever this angle is, its sine, or this is the angle which when you take the sine of it, you get x, or x over 1, which is x. Alright, so we can use the Pythagorean Theorem to find out what the other side is. We'll call it a. A squared plus x squared equals 1 squared. A equals square root of 1 minus x squared. That's what a is. So in this problem, we're asked to find the cosine of this angle. And we know the cosine is going to be a over 1. So the cosine, so the answer to this whole thing, cosine sine to the minus 1 x equals a over hypotenuse. That's this over 1, which is just the same as that. Okay? There it is. Very nice. So you can solve these even if it's some weird number by turning it sort of into a ratio, making a triangle like that, figuring out what the other side is, and out pops the solution. Very nice. Works with tangent too. You can combine these, cosine and arctangent. You can even go the other way. We rarely do that. Okay? Good.